From far away, these two graphs look different. This one is y equals sine x, and this one is y equals x. But watch what happens when we zoom in near 0. The two graphs almost overlap, so here is the question. Why is sine x almost equal to x near 0? And before we answer, there is one very important detail. This only works when x is measured in radians, not degrees. In fact, this small idea is behind many famous limits. For example, near 0, sine of 3x behaves almost like 3x. So sine of 3x over 4x becomes almost 3x over 4x, and that gives 3/4. But why is this allowed? The cleanest explanation comes from the unit circle. Take a small positive angle x, measured in radians. Because the circle has radius 1, the arc length is exactly x. Now look at three quantities in the picture. First, the vertical height on the circle is sine x. Second, the arc length is x. Third, the tangent segment is tangent x. For a small positive angle, the picture shows this order. Sine x is less than x, and x is less than tangent x. So we have sine x less than tangent x. Now we turn this geometric picture into a limit. After dividing and simplifying, this becomes cosine x is less than sine x over x, and sine x over x is less than 1. Now let x approach 0. The left side, cosine x, approaches 1. The right side is already 1. So the middle expression is trapped between two quantities that both approach 1. By the squeeze theorem, sine x over x must also approach 1. So the limit as x approaches 0 of sine x over x is 1. And that is the precise meaning of near 0 sine x behaves like x. The same conclusion also works from the left side of 0, so the two-sided limit is 1. There is also a second viewpoint. The Maclaurin expansion of sine x is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus and so on. When x is very small, x cubed x to the 5th, and the higher powers become much smaller than x. So the first term dominates. That is why near 0 sine x is approximately x. And this is why small angle limits become much easier. For example, sine of 5x over sine of 3x. Near 0, sine of 5x behaves like 5x, and sine of 3x behaves like 3x. So the fraction behaves like 5x over 3x. The x cancels, and the limit is 5/3. So this is not just a memorized trick. In radians, the geometry of the unit circle forces sine x over x to approach 1. And that is why sine x is almost equal to x near 0.